So welcome everybody. My name is Krzysztof Mędrela and I'm Python trainer. I conduct courses and workshops. Most of the time it's 3 to 5 days and it's for Python developers like you, working in companies in Poland and Europe. Now, one of the topics that I specialize in is testing. And that's why today I'd like to share my experience about a very, very hot topic, that is test-driven development. Now, who has ever heard about TDD? Please raise your hands. Okay, great. Most of you, or maybe even all of you. Now, who has ever used TDD or tried TDD on a side project or on a programming exercise? It doesn't have to be anything serious. Please raise your hand. Okay. Did you like it? Me too. Okay, so a lot of you. And do you use TDD at work with success? Oh, a few of you. But still, most of you tried TDD and used TDD, but it really doesn't work at TDD. And why is it like that? This is the question that I would like to answer during this talk. And to answer this question, we need to observe one person solving an exercise using TDD. And I won't ask for any volunteers, I will do this on my own, so don't worry. So I mentioned that I do not assume that you you know actually what TDD is. So maybe just let me quickly recap what TDD is. Okay, so TDD has very, very few rules, so I can explain them even in 2 minutes. So TDD is just a way of developing software in which we work in iterations, and each iteration can be very short, even less than 1 minute. And each cycle consists of 3 steps. The first thing is that we write a test, and it should be only one test, and the simplest possible test. So later on, in later iterations, we will cover more complicated cases, and even edge cases, but in the very first iteration, we focus just on the simplest case. Now, it should be also a failing test, because if it passes, that means that it tests functionality that is already implemented, and we don't want this kind of tests. Now, the second step is that we write implementation. And here again, we write the simplest possible code, the simplest possible implementation that passes all tests. So we do not implement any functionality that is not tested yet. And the third thing is that we refactor both implementation and tests. Refactoring is just improving code, its readability, its maintainability without changing any behavior or functionality. So it's stuff like splitting long functions into smaller ones or using meaningful names for variables. And we repeat and repeat over and over until we implement all the functionality that we need. And that's everything about TDD. There really is nothing more. The catch is in the execution, but that's later. Now, I mentioned that we need an exercise. So let me quickly explain what the exercise is about. Okay, one moment. Okay, so the exercise is pretty simple. What we want to implement is a data structure called recently used list. And we can create an empty list and its length should be 0. We need to implement the len special method if we want to support len function. Of course, an empty list is not really useful, so we can insert items into this list, and they are stored in LIFO order. So the last in is first out. And again, if you want to support indexing like here, we need to implement getItem special method. Now, Python is a very nice language because if you implement both getItem and len special methods, you get support for converting your data structure into a list for free. So this should work. And again, you can see that the order is reversed. And the last thing is what really differentiates this data structure from just a purely for queue. So if you try to insert an item that is already present in this list, like the second item, what really happens is that this item is moved to the beginning of the list. You can see that here. So there are no duplicates on this list. And this data structure is very useful if you want to display a window with a list of recently opened files or a list of recently executed actions, whatever. You don't want any duplicates on such a list, and you want to sort it so that the most recent item is at the top. And that's all that we want in this exercise. So now question for you, is there anything I can clarify about this exercise? Okay, so let's go into live coding. So, one thing, can I make it a little bit smaller or? Okay. So we start from the very first thing, that is writing a test. And now, what is the simplest thing I could test? Do you have any idea? Any idea? Yes. An empty list, yes, but what exactly could we test? Okay, so one idea is to just test if I can create an empty list and if its length is equal 0. And yes, this test is very simple. It's also a failing test, so it's quite good test. But I would say that there is even something much more, well, just simpler that we could test. First of all, we could just test if we can actually create an empty list. Yes, because we don't have even something like recently used list. And you can see that when I run this test, that it fails, of course, because there is nothing like recently used list yet. So now we can move to the second step, and the second step is, of course, very easy. We just need to implement an empty class. And just for a moment, I also need to import it. So now, what should I do now? Yes, run test, because I need to make sure that this test now passes, and yes, it passes. So the next thing that I need to do is to refactor. So maybe let's start with the implementation. Is there anything that we can improve here? Not really. And in the tests, can we improve anything? Yes, exactly. The name is just a boil. Now it's just empty. So maybe just test creating an empty instance or just an empty list. And what should I do now? Yes, run tests, because after each refactoring step, I need to make sure that I didn't break anything. So let's just run tests. And yes, everything now works. So is there anything else I could improve in this in tests? Not really. Okay, so let's go to the next iteration. Of course, we need the next iteration because we actually didn't implement it almost anything. So now, what is the next thing that we can test?
An empty list.
Sorry?
An empty list.
Yes, an empty list, and probably just checking the length of an empty list. So this is what was proposed before. And of course, now I need to run test to make sure that it's a failing test. And yes, this test fails. So now I can move to the second step. And now what is the simplest implementation that passes this test? Yes, so one thing that we could do is to just create an internal counter or maybe even internal list that stores items and then return the length of this list. But again, what we really want to do is to... Yes, exactly. This is what I want to do. But the point is, because of course, probably what we do in practice is that we just create an internal list. We store items on this list and then return the length of this list. But just because we want to follow TDD strictly, we want to just write the simplest possible code. And this is the simplest code that passes all tests. Yes, we don't write a code or we don't implement a piece of functionality that is not tested yet. And so far, we test only an empty list. So we can assume that it should return 0 all the time. So yes, I run the tests, they pass, so I can move to the next step, that is refactoring. I cannot improve anything in implementation. Is there anything in tests?
The test name.
Yes, of course, the test name. So maybe test test length of an empty list. And now I again need to run tests just to make sure that I didn't break anything during refactoring. Now there is nothing more that I could improve in tests, so we can move to the next iteration. So what could I test now?
Not empty list.
Yes, not an empty list. But what exactly you mean when you say a non-empty list? What could we exactly test?
Insert method.
Okay, so we insert something. And now, what we actually test for?
The length increased by 1, by the amount of items that were inserted.
Mm-hmm. Yes, so yes, we can check if the length is now 1. So if the list resized. So now let's run tests to make sure that it fails. Yes, it fails. So we can move to the second step. And of course, we need to implement the insert method that accepts an item. And well, let's just do nothing for a moment. We also need, no, we don't need anything more. What we need to do is to actually now don't cheat and store items, or not really store items, because we can just count them, which is much simpler. So what we want to do is to just remember the length of the list, and in the insert method, we only increment the length method. And of course, I also need to initialize length to 0. And now when I run tests, they pass. So now, sorry? Not really cheating, it's just following TDD rules. So now time for refactoring, and again there is nothing to improve in implementation, but what about tests? Well, of course there is, we can rename this test, like test, just inserting an item. And again I run tests and they pass.
Maybe better length after insert.
Okay.
We could also after insert just other, for example.
Okay, so we want to.
Length of non-empty list.
Sorry?
Length of non-empty list.
Yes. Okay. So the idea is to include in the name of the test what is the assertion. So we don't include include not only the what we test, that is inserting an item, but also what is the expected result. Yes. So test when inserting an item, then the list should resize. But it's not really, well, it can be done in this way. It can be also just test inserting an item. In my opinion, both are good. Sorry?
Then you should check whether the item is present.
Yes, but this is the idea for the next test. Okay?
So it should be named, in my opinion, test length after insert.
Okay, test length after inserting an item. Yes, it's more precise now. And it's not too long yet. So, okay, let's run tests to make sure that it works. And now, I don't think there is anything else we could improve. So we can move to the next iteration. So now, finally, we can actually test something more complicated, like maybe just test if the item is really stored. So test, just test for a moment. We have the refactoring step, so I can improve it, I can rename it in the refactoring step. And for a moment, just ignore the name of the test. So it will be something very similar, but the assertion is different. So what I really want to test is if the item is stored at the first index. And now I run tests to make sure that it fails. So now I can move to writing implementation. And now, of course, I could just return the item in getItem special method, but maybe let's stop cheating and let's do the real work. And this is actually something tricky in TDD, because sometimes you get to the point where you actually cannot pass all tests by just adding one method or just doing a small change, and we actually need to rewrite everything from scratch. So how to do that, but just in small steps? Well, I will just comment everything out, and what we will do is we will pass tests one by one. Yes, so first I want to make sure that the first test passes. And yes, it passes, and the other ones fail. So now I can focus then on the next one. It was about the length on an empty list. So I need the length method. And now I need to store items instead of just counting them. So it will be something like that. But in the init, I need to initialize items. And now I run tests. And now the first two tests should pass. Let's make sure that it's really the case. And yes, the first one passes and the second one. So now I can focus on the third test. That is just inserting an item. Or actually insert it on the 0 position. And yes, and now if I run tests, we can see that the 3 first tests pass. So now we rewrote everything, but still the last test is failing. So now we can come back to the second step of TDD, that is making this test green. So now it's not that really hard. We just implement getItem method, and we delegate to self items. And make sure that it works. Yes, now all tests pass. So now it's time for refactoring. And is there anything we can improve in implementation?
Delete this comment.
Yes, delete commented code, yes. And now I need to run tests to make sure that I didn't break anything. Yes, they pass. Anything else? Okay, okay, so there is nothing more that we can improve in implementation. So we can move to tests. And yes, we can rename it. Maybe test storing Or no. Okay, we can actually merge the two last tests because they differ only in assertions, so it's not really, it's not a bad idea. It's still easy to maintain this kind of test, even if we have more than one assertion in a test. Now I make sure that everything still works. Anything else?
The name should be
Yes. So now we can just rename it to test inserting an item, because we test actually two things. There are two assertions. So it's easier to just include what action is tested in the name, and do not include what is the expected behavior, what is the expected result. So again, let's run tests and they pass. Anything else? Sorry, once again. Yes, we could. Well, yes, there is no assertion, but this is not a bad thing, because what we test is actually that we can create an empty instance. So what we test for is that there is no exception here. Yes, we could actually merge the first two tests, but maybe just for clarity, let's keep it as it is. Okay, so I think that there is one more thing that we can do. There is a little bit of repetition of the application. We have this magic value twice, so we can extract it into a variable and then reuse it. And again, run tests just to make sure that we didn't break anything. Anything else? Now, how much time do we have? I don't know when I started, so okay, we don't have to finish this exercise because that's not the point of the talk. This exercise is pretty easy, but the point that I'm trying to make is that we saw TDD in action, and I spent something like, I don't know, maybe 15 minutes on this exercise. But on the other side, if I didn't have to follow all the TDD rules, write tests, and so on, I could solve it in, I think, 3 minutes or something like that. And now the question is, what's the point of TDD? Because you cannot be that slow at work. So it's just useless. But on the other side, I mentioned I'm Python trainer and I conduct courses and workshops, and I include this exercise in my workshops. So why do I include it even though it's useless? When you work on a big project, on a real project, and you want to implement a change, it can be a bug fix, it can be implementing a new piece of functionality, whatever, there are two issues or two bad things that can happen. So the first one is that the task that you want to do, the change that you want to do, is so big that you don't know how to split it into small steps. But even when you know how to split this big task into A, B, C, and then D, there is second danger. So you start A, you run tests, and everything works. And then you move to B, you do B, you run tests, and this module works. But suddenly, something is broken there. So you just go there, you're thinking, how can I fix that? Okay, I need to do E, F, and G. So you do E, you run tests, everything works. You do F, you run tests, and then suddenly it's broken there, but also there and there. So you just go maybe there, just for a moment. And you guessed correctly, after some time everything is broken, but what's really bad is that you lose track of where you are, what is the next step to do, and where you started from. And these are two very important skills that we need as developers, yes? Splitting big tasks into small steps, and then keeping track of what is the next thing to do. Now, if you look at this exercise, it's The exercise is very simple, very easy. You all can solve it in, I don't know, 5 minutes or something like that. But just because we had to follow TDD rules, we had to split even so simple task, so simple exercise into small steps, into baby steps. The first step was to just write an empty class. Then we implemented length special method that returned hard-coded 0. Then we counted items instead of storing them, and so on and so on. And on top of that, we had the algorithm, the TDD algorithm that helped us keep on track so that we knew what was the next step to do. And this is why TDD and exercises like this are so useful, because we improved our two very important skills, that is splitting big tasks into small steps and then keeping track of where we are. Okay, to sum up, TDD is maybe not useless, but it's hard to use TDD at work because we are too slow. But just exercising TDD is very, very useful because it makes us just better programmers, because we develop these two very important skills that are necessary if we want to work on big projects. Okay, thank you very much. I think we have a lot of time for questions now. So who wants to ask a question?
What's the name of the editor that you used?
Visual Studio Code.
Why? No, my real question is, what is the right amount of, as you said, cheating in this process? When you use the TDD in real life, when do you stop implementing fake LAN methods or something, and you start writing real code, like in the third or fourth step you showed?
Okay, so the basic idea is that if I want to do too much at once and I got lost, that means that, well, I'm trying to do too much, so I need to split it into smaller steps. But if it takes too much time to solve this exercise, because, well, there is deadline or something like that, it's usually obvious that you are doing it, that you are making two small steps. Most of the time, I don't have any issues with. It's very rare for me to make two small steps, so I don't think that there is that danger of making two small steps and then just cheating, because it's pretty obvious when you start cheating, but it's not that obvious when you are trying to do two big steps. Did I answer your question?
Yes, but the border is time connected. So if you solve the problem for like 5 minutes, it's too much, and you start cheating or anything, right? Or the complexity is.
Yes, I think this is a good heuristic, the time that it takes to do one step. It shouldn't be something like, I don't know, 1 minute, because then you are cheating like that. But when you cannot do one step, you cannot move forward in, I don't know, 1 day, that's definitively a sign that you need to split it into something smaller. Yes?
Do you find TDD rather as an exercise of your programming skills, like just for your own attitude, or do you use it for work? Because the thing you show us, this really orthodox TDD, I cannot imagine a situation at work that it will be useful.
Yes, so the strict version, the orthodox version that I presented, yes, it's just useful at work. But you can just pick some rules from TDD, or maybe just not be. Well, I just use it at work, but not the strict version like I presented here today. But still, it was like using most of these rules. So we can just pick up a few of these rules, maybe not be that strict, and it definitively can be useful at work, but not the strict version. Okay, the next question. Can you?
Pretty nice
Sorry.
presentation. But right now you said that you're not using a strict version of the TDD at work. Could you explain why you're not using strict version?
Because you're not
Well.
paid by the hour.
Oh, sorry. Yes, because I have deadlines, so I cannot be that slow like here today. Yes, if you are strict about TDD and you want to do 2 small steps, like baby steps today, then it takes too much time. So I just cannot afford working so slow.
Does it mean you're focused on most important parts?
Sorry?
Are you focusing on most important parts?
So the question is if I'm focusing on the most important parts. You mean on most important parts in TDD? Yes. Yes, basically yes.
So if you do not follow this automatic version, so how do you decide when you have a function if you are going to follow an like orthodox way with this kind of function or functionality, or if you're going to skip it and just assume that you are going to get it right on the first try and you don't need to implement this function?
Okay, so the heuristic is just the time that it takes to move the issue forward. So if I can solve something in, I don't know, something in less than 1 hour, then I don't have to split it into some smaller steps and so on. So I can just do this in whatever way I can do this. But
how do you know that you can, that you are going to solve it within 1 hour? It's like a prediction, right? So
yes, so it's just a guesstimation. So I just guess, and if I finish it in 1 hour, then I was right. If not, then I need to revise my guesstimation, and I need to start using, for example, TDD, or definitively I need to split it into some smaller tasks. So it's just estimation, but I can be wrong about the estimation, and I am very often. Okay, I think we need to finish. So thank you very much again.